Okay, so let's get started. If anyone else joins, then I'll catch up. So my name's Szczepan Wójcik. I'm a cloud DevOps engineer. So that the topic is related to what I do. It's Terraform. So I have, I think, 16 years of experience, but not all DevOps. Previously, I'm with Shaping the Future now, working on cloud, particularly Azure, where I use Terraform to build cloud infrastructure defined as code. So I will show you in this webinar what it means and how this tool is to be used. And in general, this is meant for anyone who's interested in the topic. So you don't have to know much about cloud at all or about cloud DevOps. So anyone who would like to experiment with cloud providers and do infrastructure in this way is welcome to learn a bit about that. So let's get started on what Terraform is. And I don't have many slides here. The entire webinar is mostly to show you how it works. But in principle, Terraform is a widely used tool to provision resources from the major cloud providers, so basically AWS, Azure, Google Cloud Platform. It's also used for other types of infrastructure, but these three by far are the top solutions that is being used for. So you will hear about Terraform whenever there's any of the three cloud providers mentioned, and yeah, it's pretty common nowadays. And it's also a programming language, so it's called a HashiCorp configuration language, or HCL for short. So it is infrastructure as code. In other words, you're basically writing some code that defines the infrastructure you need. So what do you need to get started to do it yourself? And the aim of this webinar is maybe some of you will decide that you like it and you'd like to try it yourself. You basically have to have an account with a provider. Each of them, they give you 12-month free tier where you can use some services, usually like those smaller VM sizes, a lot of restrictions, but nevertheless you can do a lot with that. You need the command line interface tool that you need to install. So in this case, we'll use Azure, so the Azure command line interface. Then you just need to download the Terraform binary and basically log in to that account you created, and you can start creating infrastructure. So with that being said, I have an account here that is completely empty in Azure. I have an empty project that I'd like to create here with you. And yeah, maybe just let me just check. Here's the Azure command line interface. It's showing me that I'm logged in, and we can start creating some infrastructure here. And now you can use any editor. I have here Visual Studio Code, could be any editor, and we'll start creating some infrastructure. So we'll create a file, a Terraform file, the standard way is to name like the main file, main.tf, and we need to add some definitions of what we're going to do here. So one thing is that we need to define that we'll be using the Azure Resource Manager provider. If you're using AWS, it will be the AWS provider. If Google Cloud Platform, this will be the G Cloud provider. So that's one thing. And then we need to define the resources we'd like to create. So in this case, in Azure, there's something called a resource group, where we will create resources. And basically the structure of Terraform is that you have like resource definition, here, and parameters, like what is going to be name and location, West Europe, which is basically Amsterdam. We need a little bit more to have something running. So I have some definitions ready. I'm just going to copy here. I'm too lazy to type it all. So basically a virtual network and a subnet. And now we can almost be ready to add that virtual machine. But first we need to have the network interface. So here's another definition that basically says this network interface for the virtual machine, and an IP configuration. So this will be here connected to the subnet we have above, and a private IP address. And by the way, I forgot to mention the important point that the goal here is to provision a virtual machine. So that's what we will be doing. All right, and now let me copy some more of the definitions, so we can actually start to add the virtual machine definition here. So this is just another resource. So again, machine name, this is the size, this will be a 2-core machine, will be the name of the admin user. But we also need some additional information that we need to pass here, which is one, we need to create a disk, and you know, these are just samples that you're going to find a lot like these in documentation and on the internet. So don't worry about noting this down. I'll just try to show you how it's going to work. So that's one thing. We also need to have a way to log in. So I'll copy an admin key. This will just basically copy my public key to the virtual machine, so that I'll be able to log in. And one more thing that we will need is a definition of what image we're going to use. So here I have a section, and this is the last one actually we need to get started. This is the definition of what we like to provision. So we're basically going to use a standard Ubuntu image. So, and you can look those up in many places. So we need the SKU definition. So this will be version 20.04, and actually the SKU, and version table name latest. Okay, so here's our entire code. And now's the question, what do we do with that? What do we do with that? And here are some key commands, and these are all the commands that we need for today's webinar. And on the left here, these are the commands that help you prepare the project before you actually try to deploy it. And the ones on the right are about deployment. So the ones on the right are when you're ready and you'd like to deploy this project. So we'll focus on the ones on the left first. And Terraform Fmt. So you probably used, if you're coding, that in your editor, there's some plugin that formats the code. With Terraform, that comes with the binary. So let's say I have, some ugly formatting, just to make sure we'll see that in action. I'm going to write the type, so Terraform format, and it basically formats the code to some standard. Okay, so what's next? We need to run Terraform init, so it initializes the project. Let's run it and let's see what it'll do. Terraform init. Initializing the backend, and it's initializing the Azure Resource Manager provider. Green. It's all good. Let's go back to our project. We see there are some files created. So there's a log file here, and there's a .terraform folder. So yeah, these are some files that Terraform basically creates when you initialize the project. They tell Terraform what provider is going to use. So Azure Resource Manager here, and yeah, we're good. If you change anything, you might need to run that Terraform init, such as the version of the provider, if you have additional providers. But for our example, we just need to run it once. So let's run Terraform Validate. This will validate the code and let us know if we have any errors here. Okay, so Terraform Validate. Okay, says configuration is valid. Thankfully, no errors. So now we can think about deploying this project. So if you look here on the right, we have actually like 3 commands: plan, apply, and destroy. And if you're working with Terraform, you're going to use them a lot. Actually, all the commands here on the screen, apart from init. But with plan, apply, destroy, this is a 2-step process when you're creating infrastructure. Terraform plan is basically going to tell you what infrastructure is going to be created or modified. So if you already have something created, you made some changes, you added something, and this is what we'll be doing here. That will show us what needs to be added and what needs to be modified. And then once we're satisfied with that, we can use the apply command, which will actually create the resources. Now, destroy, as the name suggests, basically destroys the infrastructure. So we will try that as well. Then let's use the Terraform plan command and see what it will do. does take some time, depending on the complexity of the project, but hopefully it'll finish in a reasonable time. Okay, here we go. So here Terraform said that the plan is that it needs to create 5 resources. It would change no resources and will destroy no resources, which is not unexpected because we don't have anything yet, so there's nothing to change. We can review the entire plan. So we have all those resources that we have defined in the code. They have some additional parameters which maybe we didn't set, but they just have some default values. So we have the virtual machine here. We have the network interface. We have the resource group, the subnet, and the virtual network. So 5 resources. Now we can do the apply command. But before we do that, let me just quickly check if here in Azure, if we have everything destroyed. I just have here one resource group, and that is just network watcher. That's something that Azure does on its own automatically. So let's here hit Terraform apply, and hopefully on the left we'll soon see the resource group with the VM created. Terraform apply actually runs the plan again, but after running the plan, so it's, as you see, the same plan, 5 resources to add, it asks us to confirm. So we have to type yes specifically to proceed with the deployment. So that's what we're going to do. Yes, and let's see how it goes. Okay, so here Terraform as we go is basically showing which resources it's creating. There's lots of output. We see it's now doing the virtual machine. Depending on what exactly we're provisioning, it may take some time. A VM in Azure, that's roughly typically less than a minute, but if you're creating, for instance, I mean, larger projects, Kubernetes clusters may take up like even 10 minutes or even longer at times. So we have to be patient for a while. But as we go, I can actually try to refresh here. And as you see, we have this resource group already. We can go into it and here see the progress. Right now, there's only virtual network visible. Let me maybe, okay, so Terraform said it's apply complete, 5 resources added. So let's focus for a while on this resource group and see if we have what we needed. Okay, so here you see 4 resources because the resource group is a resource as well. So that's 5 in total. So this is the virtual machine we created, and it is working. But we don't have a public IP address here. So we cannot connect to it because it only has a private IP address. So this is something, the first thing we have to fix here. So I'm going to open the project again, and here add some missing resource. So maybe just before the order actually doesn't matter. Terraform is going to figure out which resources depend on which, but just for the sake of preserving, maybe just use this name. We're going to add resource called public IP. And we also need to assign it to the network interface. So here I also have examples. So here in the network interface, we have another option. And by the way, all of this, those resources, they're documented. So you can go to, or you can Google them. You go to Terraform Documentation, and you have all the information what each of those fields mean. So yeah, based on examples like this one and based on documentation, you can figure out what you need to achieve. So we've made the changes, and let's start by making sure our code is formatted. So that's done. Then we can validate it again, now that we make changes. Okay, configuration valid. And now that we have those changes validate, let's see what Terraform plan would show us. Remember, we've added the public IP here, and we also associated it with the network interface. So these are the changes we made, and let's see how it looks in the Terraform plan stage. Terraform should basically reconcile what is currently provisioned and what we just defined as additional things. Okay, so here's the plan. It's one resource to add and one resource to change. So that's the summary, and we can see here that the public IP address will be created. So this is the resource we defined, but the resource network interface will be updated in place. So it means that it's not going to be removed and replaced. It's going to stay the same resource, and it's going to be basically updated. And here, like with this green plus symbol, you see that this one parameter, what public IP is assigned, will basically be changed. And how does Terraform know that? How does it know what needs to be changed, what needs to be done? So it maintains a state file. So perhaps I should have mentioned after that apply command that we ran, this is a file that's been created, terraform.tfstate. So this is the so-called state file that Terraform creates, and it stores in JSON format all of the resources that it created with all the parameters. So it knows what is basically the state of the configuration. So now, if we make any changes in the code definition, then it'll reconcile those changes and tell us what modifications need to be done. So that's why the state file is important. If I were to remove it, then it would, I think that we don't have anything. We have to create everything from scratch. So that's why the state file is important. Now, let's basically apply this plan and see if we will get this public IP address. If we will get this public IP address. So again, Terraform apply also does the plan as we just did a moment before, but it also asks us if we'd like to proceed. So again, I'll type yes, and let's try to get this public IP added to our VM. Now, here's the virtual machine. Again, it didn't have the public IP address yet, but we're hoping it'll be here any moment now. Okay, says apply complete. Let's refresh the Azure portal and see if that VM. Okay, here it has an IP address. Let me try to log into that virtual machine and see if it's working. So I think I had Azure user as the admin username. I have to confirm the key. All right, looks like it's working. So we have this Ubuntu box that is running. Okay, so we're good. We can log out. All right, what else can we do? That may be interesting. So one thing is, as you noticed, I had to basically go to Azure portal to look up this IP address. But with Terraform, there is something called outputs, which are different resources, which we can add to the project. So I'm basically the name. I'm basically outputting the IP address from this machine. So Azure Linux Virtual Machine .example.public IP address, which is a parameter of this. Again, this is in the documentation, but it basically points to this field. So we'd like to see this field once we apply. So very quickly, let's again make sure we have the code formatted, run validate. And let's go straight to apply, because this is just an output. So there shouldn't be any changes now if we Terraform apply, but it should show us the output definition that we are looking for. Okay. Oh, it actually changes to output, so it isn't going to modify anything, but yeah, nevertheless, that's for confirmation. So here is the output that we will now see every time we do something. If for some reason, like we destroy the infrastructure we created again, then you'll always have the output here with the IP address that is current. What else can we do? Now that this project has grown a bit, we can think about organizing it better. So for instance, one practice is that we do separate files, and for instance, we can move the output definition to a separate file. So I remove it from here and put it in the outputs .tf file. Terraform basically combines all the files with .tf extension and treats them as one in alphabetical order, but it doesn't matter most of the time because it sees like dependencies between each resources, and you can you can just organize it by what is meant for what. So this is one thing we can do. Another thing, for instance, that we can come up with is add one parameter to that public IP address. Let me just see where I have it in my notes. Okay, doesn't matter, like we'll figure this out. But one more thing that we can do is basically use variables. So again, we could put them here under this file, but we're going to add another file, variables, and again, like these three will be combined. And here we can define some variables. So let's, for instance, define the location which we're going to use. So here is a definition of a variable, location, but that's just definition. We also need a file that stores the values of the variables. So these are a tf-vars file. Okay, here we go. And here we can specify the value of this variable. So let me maybe move it to the bottom here. Okay, so here's and here are the variables. Okay. All right. Yeah, so I now have the location variable, which I'm setting here. And now we can reference this variable instead of typing it directly in the code. So I'll just type var location. We'll do the format first. Okay. And it formatted actually this file only. So let's see if it still works. It shouldn't have any changes. So let's do validate, then plan, then apply. And once we're done with that, we can try to do something useful, actually run something on this server. Okay, so this is valid. Now we can plan. All right. Okay, so there's no changes. So all good. We just reform. We basically, to summarize, we basically moved the outputs definition to a separate file. But for Terraform, it doesn't matter much because it combines those files. And we basically moved the definition of the location, so the West Europe pure region, into a variable. So it's defined here as the variable, as the string, and here as the value. But it doesn't change because once Terraform combines it all, it's the same result. So now we can try to run something on this server. I'll create here a simple script. And so those of you who are familiar with Linux probably know a bit how it's going to work, but it doesn't matter much anyway. This will just be simple commands to install an Nginx web server. Yeah, so this simple script basically through update and install the Nginx server. So that's one thing. And here we're going to use a feature that's in Azure, pass the custom script with one parameter. So let's perhaps add it here. Okay, and we can try to apply it. So again, let's make sure the code is formatted and validated. Okay, and then let's see what the plan tells us. It's probably, I'm guessing, is going to recreate the entire virtual machine because it has to provision that. But yeah, sometimes it may just run it without replacing it. You never know, but that's what the plan command is for. It will tell you what's going to happen. Yeah, exactly. It says one resource to destroy, one to add. And as you can see here, it says that the virtual machine needs to be replaced. So that's why the plan command is important, because imagine you're doing this in a production environment, then you want to make sure that you're not destroying something unnecessarily. And here you can also see that there will be changes to output. So right now we have this IP address, but after applying, it may be something different. So that's why it says it's known after apply. Okay, so let's try our luck. Terraform apply and see what happens. And yeah, as a reminder, this is basically the single line that we've added to run the script that will install Nginx. Okay, the same plan. Let's type yes. Okay, so now it's destroying this virtual machine. And once it destroys it, it'll start creating the new one. So this will take this will take some more time, because actually more than deploying it from scratch, I think. And on a side note, what are the benefits of using this infrastructure as code? So obviously, all of this we could create using the portal. We can just click here, create resource, or maybe create virtual machine. And basically put all those settings here. But if we like to create 10 or 20 or more virtual machines, that obviously it will take a lot of time, and we wouldn't be, unless we are very, very careful, we would probably make some mistakes and they would be different. So if you have it defined as code, then you will always get the consistent results. Plus, for instance, for experimenting, you can quickly create this resources such as VMs and destroy them when they're not needed. So imagine you just need some development box. So that's basically the quickest thing to do. Okay, we have the new VM created. It has this new public IP address. So let's actually try and see if the server is running. I hope it is. So I'm going to type, and here it is. Welcome to Nginx. So for all of you on the channel, let me just paste the IP address for those who like to check it themselves. Yeah, we have the server running, but it's just an IP address. So maybe there's some better way to make it more easier to type and remember, and we can simply add a domain name label to the public IP address. So here, okay, I actually have it. I haven't removed it, so it's here. Maybe let's pick a different name, because I was supposed to add this later on. So let's do maybe webinar. Let's do that. And also, because we like to learn what this domain label is, let's add another output that will show us. But here, and again, this is something that look up in the documentation, there's the fully qualified domain name parameter. So once we have that, it will basically use this label for Azure DNS, and here as output, it will give us not just the short name, but the full DNS name that will hopefully be able to use to access the server. So again, let's make sure the code is formatted, validate the syntax, and then plan. Yeah, this will at least modify the IP address, but maybe replace it. We just have to check. So depending on that, yeah, the IP address may change again. Right. And actually, once we do that, once this succeeds, and I hope it will. Okay, yeah, so it says one resource to change, and is this public IP address. So it'll be updated in place, which means the IP address should stay the same. So let's apply. Let's apply, and hopefully we will have the the entire address here instead of the IP address. Right, and once we do that, then we have the functional example VM running with some server. So then we can jump to Q&As. So you can think about your questions that you have about Terraform or what we've been doing right now. So yeah, I feel free to basically type your questions in the chat. Yeah, but keep them short, ideally, maybe 2-3 sentences, like maybe no more than 2, and I'll try to answer them. Okay, so let's apply the changes, and we shall have a functional address that we can access instead of the IP. Okay, says one changed, and here's the output with the fully qualified domain name. So I'm going to copy this and open it instead of the IP address. Okay, not yet ready. Maybe we have to wait a bit more. Or this is weird because it's supposed to have changed the TF example to TF webinar. But it didn't output the entire thing correctly, which is weird. So you see things not always work as they're supposed to, but let's see if this works. Okay, this works, but that is weird that the output didn't get updated. Yeah, so we have this address running. Let me just paste it for everyone who'd like to test it, maybe hack it. And yeah, so one more thing that we obviously would want to do is, again, here we have this resource group. We can destroy the entire infrastructure. So, and those of you who would like to try the address, please do it quickly, because I'm typing destroy, and this will destroy all infrastructure. So if you're doing development, if you'd like to quickly check something and try something on like different types of operating systems, different Linux distributions, like this is a great way to test configuration. Okay, we have one question from Kamil. What if somebody changed configuration of your VM from Azure website? How to make TF state file consistent with new configuration? So that's a good question, and we can actually test it. So the Terraform refreshes the configuration, so it should import the changes, but yeah, depending on how many things are changed, especially they're recreated, it may result in different things, because if you, for instance, if you add something here or remove and replace it, Terraform may not know about the resource that you add here. We can actually try to do a manual change here and see if it's going to be reflected with Terraform. Probably depends, but yeah, as usual, the best way is to test, experiment, and make sure, yeah, before you apply something, you have the plan, the Terraform plan, basically. Yeah, feel free to add questions. if you have any. If we're not out of time in between, then we can try to do this example that Kamil just suggested. So I'll create the infrastructure again, change something, and see how Terraform behaves in that scenario. Oh, and maybe to show you that documentation. So, for instance, we've been recently changing this Azure RM public IP. So, yeah, you can just Google the resource name, and here's Terraform documentation for it. So you have examples similar to what we've used, and you have the all those fields defined. So, for instance, we use this fully qualified domain name as output. You can look up each of those items. Okay, in the meantime, we had our infrastructure destroyed. Let's see if it is indeed destroyed. Okay, the entire resource group disappeared. So we can now apply it again. So it's recreated, and then we can try to change some settings and see how Terraform behaves in that scenario. Right. So I really encourage you to try this out. Like, this is a really quick way to set up infrastructure. You, as a reminder, like if someone joined later, you can create a 12-month free tier account with any cloud provider. Azure, as we have in this example, but any cloud provider will do. Basically, download the command line interface, Terraform binary, and you can do like pretty much what we've been doing here. And that was my idea, so that if you like it, then yeah, hopefully someone will try start using that after this webinar. Any other questions? And again, we have the infrastructure being created. So refreshing here, we should be able to see it shortly. But the portal may be slow at times. Let's open it again like this. Okay, here it is. So we have this resource group being created. Again, once we have it, we'll try to make some changes and see how it's reflected with Terraform. Okay, we have it. Yeah, what can we change, for instance? Okay, VM name size. We would have to stop it and run it again. Let me see where. Actually, doing everything in Terraform, so not sure where to change the name here, but or maybe something simpler like the public IP address. Okay, well, we're just going to change the DNS name label as TF webinar 2 and see how that goes. So we're saving that, and Terraform is not aware of that because in the TF state file, if we look for the fully qualified domain name, yeah, this is the value it has without the 2. But let's see what will happen in this scenario. First, need to make sure that that Azure made the changes, and now let's do plan. Plan is probably, yeah, can't really tell what it's going to be. But in principle, the best approach is to, like, if you're deciding for Terraform, and especially in production, is to only use Terraform, because otherwise you may have some unexpected results. Okay, it did actually refresh the state. So as you see, it yeah, it will change it back to here. So let's apply, and then we should get back to it. Yeah, so in this scenario, thankfully the question's answered. We have it done. Okay, so this will conclude the webinar and the Q&A. So I'd like to thank everyone who joined. Yeah, and hopefully, and this was the goal of this session, to encourage you to try this tool, and yeah, maybe incorporate it in some of your projects. Yeah, this is basically, how I learned this, by experimenting in this way.